to you about expected business value in the quantum computing ecosystem. It's February 14th, 2020, and we're going to walk through a couple of different topics. I'll talk about myself and why I feel confident and capable to give the presentation. We'll talk about the quantum computing provider landscape, the people, the companies who make the hardware and software and bring you access to it. We'll talk about the business use cases, so early use cases for quantum technology, and then we'll close with a point of view on how a corporate or an enterprise commercial company could start to use quantum computing. So let's get going. So I'm Jeffrey Cohen. See the picture. I'm leading a quantum computing startup after 30 years in industry, leading IT management consulting firms, IT professional services practices, and working for both, large corporates. I was an IBM executive, Hewlett Packard director, I was an associate partner with McKinsey, very senior executive at Siemens. So in 30 years, built quite a career around consulting. From an education perspective, it's mostly around finance and management. Um, my work grows consultancies. And so I figured, why not do it for myself and build a startup focused on quantum? There's very few of them, maybe four in the world that we had found when we started our business. And in general, my domain is around helping clients manage IT infrastructure more efficiently and more effectively. And, over a 30-year career, been able to build the business quite substantially, up to a maximum size of $447 million a year in annual sales. So let's talk a little bit about how we group the information. So if you're a quantum computing provider, you either make hardware. So one is a full stack quantum computing provider. You make a whole computer, you provide access to it. Um, it's it's a whole stack. The second is you could be providing components or be a solution manufacturer. So we see quantum processing unit providers, dilution refrigerator makers, people who make photonics or lasers. Um, a solution would be quantum key distribution, where people make the actual boxes that sit in your data center and help secure your communications. And the third are startups. These are early funded startups or late stage startups that may not have a solution to show you, but but they're serious and they're spending money and they're building a business. The next group is software platforms, and the tools that power either the computers or help manufacturers make better computers. In some cases, we say platform provider because a company will come out and make a platform that works on multiple quantum computing technologies and multiple systems. And in fact, some of the hardware companies also make software, also provide access. And so we only list our companies once. Next is access providers. These are companies that provide access to multiple vendor solutions for quantum computing in a cloud computing framework. And then lastly are the consultancies or independent software vendors that are out in the business world. So on the use cases, we break it up into quantum computing optimization. So to optimize to come up with one answer. Or it's quantum computing non-optimization, where we're using the power of quantum to solve different types of questions than just a straight math problem. And the last is quantum technologies more generally, not computing. You'll see things. You'll see things there. Military, engineering, science, medical, chemistry. Um, that are pretty compelling cases. Just a few notes before we get into the details. All the data we're presenting to you is publicly available. We may know things that are not publicly available, but we will not disclose them due to confidentiality agreements. Second, all quantum use cases discussed are experimental, at least at the time that we documented them. They could be a proof of concept, they could be in research and development phase, they could even be on their way to production, but they're not yet in production. Our list may not be comprehensive because they're based on our team. There's one founder, there's 7 associates, and so based on our research, our experience, our network, we may have missed a few. But As people talk to us, we tend to add them right into the research. All providers are listed only once, even if they serve multiple markets. The next, some providers in some use cases leverage quantum inspired technologies, including simulation of quantum computing on classical systems. And finally, the provider data is current as of February 1st of 2020. The use case data is current as of October 1st, 2019. And lastly, Chicago Quantum is a registered service mark of U.S. Advanced Computing Infrastructure Inc., an Illinois corporation. We're going to now talk about the quantum computing hardware, software, cloud access, and consulting ecosystem. So we start off with the quantum computing hardware platform manufacturers. So you see Alibaba Cloud with the Chinese Academy of Sciences, Alpine Quantum Technologies, Atos, French company, working through their Bull hardware manufacturing facilities. D-Wave Systems out of Canada, Fujitsu IT Limited out of Japan, Google AI, truly global company, but out of California, Honeywell Quantum Systems Solutions in the US, IBM Research, again, truly a global presence in the quantum space, but out of New York, IonQ out of Canada, NTT Phi Laboratories out of Japan with a relatively newcomer here, the last one on the list, the last one added to the list. Rigetti Computing out of the U.S. and Xanadu out of Canada. And so, just to talk a little bit, some of these providers are based on superconducting qubits. So they're producing circuits, superconducting circuits, where um, it can keep track of basically a zero or a one. Then you have others that are using quantum annealing. So they're using a somewhat analog process to find the lowest energy value to solve a specific problem. And you see Cubo and icing up there. Think of them as a quadratic, unconstrained binary optimization problem. Think of it as linear algebra coming up with one best answer. And you see a number of annealing firms. You also see ion traps. So ion traps take identical atoms and they suspend them over an ion trap, and they're able to use lasers and interact with each particular ion. And the ions are identical. It's easier to manufacture and control them. And so they believe they have a better scale and a longer coherence time. And then Xanadu is the photonics company. And there's others like PsiQuantum that are also working in photonics, with the idea that if I squeeze light, I can use that squeeze light to help me with calculations. And so, a couple of things to point out. You've got simulators, and I forgot to mention Atos is making a pure play simulator of gate-based systems with no errors and based on a high memory system that would be used, let's say, for SAP HANA. So we talked about a couple different technologies, but future technologies that you'll see in the startups are using neutral atoms, not trapped ions. And you'll see some that are trying to use CMOS or today's technology, and then others that are using spin. You'll learn about Intel and others, and then topological qubits, which is the Microsoft play. So lots of new technologies on the horizon as well. Simulators today are offering comparable performance. Now, many of us have read how Google AI had a quantum supremacy experiment where they came up with one thing that is not commercially useful that runs on a quantum computer but cannot be effectively simulated. Okay, great. But for most problems, today's simulators um, can replicate the performance of today's quantum computers. And this is really a competition between very large firms, Fortune 100 firms, up to $1 trillion in market cap, and small venture cap or private firms. So let's keep going. For the quantum components, hardware component or solution makers, just to go through the list. So Blue Force out of Europe makes dilution refrigerators. Cold Quanta out of Colorado is working on transduction. It's working on transformation of wavelengths for communication. Hitachi Cambridge Labs has a pretty large research effort, and they've come to market with some really good quantum key distribution technology, as has ID Quantique, as has Toshiba Research. And so Toshiba has also come out with, other than QKD, some other technologies as well. Then you see other startups. So M Squared makes the lasers, Intel makes quantum processing units, and Infineon is working on the same type of technology. So there's still pieces missing. You'll see a note, no supplier offers quantum memory, quantum storage, I/O, true networking, database management systems. No one's offering fault tolerant systems or even fully error corrected systems. But once we get the full computers set up, then there'll be large market spaces for those. And we recognize as an incomplete list. And so it's exciting for us. And we also see a mix here of academic spin-offs, as well as large corporate research groups and small startups. So people are pulling expertise from really from all over. Let's talk about the hardware startups. And on this one, I want to show some of the technologies and the funding. So you see Atom, you see Bleximo, BrainCell, IQM Finland, Orca, Pascal, PsiQuantum. So PsiQuantum has raised $230 million dollars of funding. They have a photonics approach along with a CMOS approach. So CMOS is today's technologies coupled with photonics. Um, they're thinking that they'll have a silicon-based, photonics-based computer, quantum computer, they can build at scale. Others are going straight for neutral atoms. You see Pascal, BrainCell, and Atom. And then Orca Computing, similar to Xanadu, is basing their photonics computer based on Orca quantum memory, their own quantum memory solution. And then you see Quantum Circuits USA. Now they've already announced a deal with Microsoft Azure Quantum. And from what we see, it's a quantum app dev platform and possibly a hardware stack. And then Quantum Motion, we have not found a lot of information about. So let's talk about software. So these are firms that may have started out in the consulting space, but have since moved into coming up with some repeatable, scalable solutions around software. So, one qubit, long-term player in the space, um, Cambridge Quantum Computing. We'll talk a little bit about Zapata. Um, these are firms that have been in the space since we started, and large teams of diverse experts, scientists, computer scientists, physicists, mathematicians, client facing people, business experts who come together. So those are your larger players. Now, Strangeworks, Riverlane, making it easy for the community to come together, helping app dev. And when you look at Quantum Benchmark Inc. and Q Control, they're really working for the manufacturers of quantum computers and helping them either manage or mitigate the noise, inherent noise in quantum systems. And so if I can correlate and separate out that noise, I can actually have a more pure environment. And so, one of the players, Asara, is offering post-quantum cryptography software as a pure play out of Canada. You've got one, Project Q, which is a ETH Zurich, offering a scalable quantum simulator without bundled hardware. And so pretty good space. All of these are relatively small players. Then we look at the cloud space, or what I call multi-vendor platform access. And so you see three players here. Amazon Web Services is a pure play with Bracket. And so they're offering a full set of services, so platform access and consulting services to companies. They also offer a simulator. So you can build on a simulator, you can run it through Bracket. You can bring in development teams from third parties. Microsoft Azure Quantum, I mean, their first announced solution after thank you, open sourcing their SDK, which is Q Sharp. Now they're offering Microsoft Azure Quantum, which is access to three systems, three different types of computer systems. As well, they're working on topological qubits and doing a ton of research to try to build their own quantum computer. And in QCware, which might surprise you, it's a much smaller company, but they do offer a cross technology, cross vendor platform. We've considered using them for our NSF grants. We probably will use them. And they offer, pay by the drink, pay by the hour. And to give credit where it's due, you will see companies like IBM that are also offering cloud access to multiple vendors. You've got Rigetti in the cloud space, although I don't know if they offer multi-vendor and others, but these are your three pure plays. Let's talk a little bit about the consulting companies and the ISVs, and we're going to ignore ourselves on this list. So starting with the big players, Accenture and Boston Consulting Group, these are typically a focused group of individuals that have a passion. So they're working within the construct of the firm, and they're helping clients to use quantum computing. They're at conferences. We see them with leaders of the industry. So then HBAR out of Australia, they have Meet the Mechanics, Spotify, and they work with clients, and they bring out some of the emerging talent in the industry. Max Kelson out of Australia, data analytics. QuantPhi out of France, by the way, terrific group of guys um, working in financial services, and then Zapata Consulting, which again is it's almost like a household name when it comes to quantum consulting. And so I'm going to end here, and then we're going to pick it back up for the quantum use cases. So thank you very much for listening. Fully quantum use cases. So these are publicly stated use cases that clients have put out into the space and are creating a story or set of stories for us to think through when we're figuring out how quantum might help our businesses. So it starts off with optimization cases. And so typically these are being run on quantum annealing systems, digital annealing systems, or simulators. And so they handle the traditional traveling salesman problem. So another way to think of it is needle in a haystack. So how do you find a needle in a haystack? Well, with classical computers, you have to look through the entire haystack sequentially, or even if you did a little parallel processing, you're looking at every possible solution in the haystack to find a needle. With a quantum computer with an annealing solution, you're just looking for the one best solution, the lowest energy solution. So that would be the equivalent of looking for the needle and finding the space where the needle probably is, and then you can then just look right there. So if we look at things like increasing an automotive paint line capacity, we're scheduling the paint line physical movements of the equipment so that we can paint more vehicles and we can avoid a multi-million dollar build of a new paint line. We're optimizing vehicle dispatch or travel routes to reduce the amount of wear and tear and the gasoline used in a vehicle. We can improve configurators for new car ordering, for digital advertising recommendations, or for ordering items for sale on a website. We can schedule robots to seal joints and seams more effectively because we're avoiding bottlenecks. We're optimizing around costs and values. And so scheduling a complex repair shop is the biggest example I've seen. There's a company with a multi-billion dollar repair shop business. This is not your local automotive. This could be, I've read it, it's over billions of dollars. I've met with the team, over billions of dollars of backlog just going into the repair shops. This is actually General Electric in the airplane business, the aviation business. And so there are pieces of equipment that you need to use. There's people that need to be scheduled. There's locations. There's also some decisions about whether I build a part or I buy a part. Do I repair something or do I replace it? And those decisions become very complex optimizations that if I can run them and come up with a solution, let's say every hour, every minute, even every day or every shift, then I can maximize my earnings through the shop and I can reduce the amount of time that my customers have to wait. It's a win-win for everyone. The challenge is that the number of possibilities for scheduling that repair shop probably exceed the number of grains of sand in the universe. And so you can't look through all the problems, all the possible solutions, and find the best one. But with a quantum annealing solution, the intuition is that yes, we can. Now let's talk about non-optimization. So these are a little more complex. The first one is chemistry, right? I can help a company find molecules or materials or commercial compounds that have certain structures, functions, and attributes that are necessary. And I can do that by doing the actual mathematics required in material simulation on a quantum computer. I can model a physical system, a quantum system on a quantum computer. At least that's the intuition. And so some of the use cases that are talked about are batteries. If I can make a better battery technology, I improve the world. Pharmaceuticals. I can take a virus, I can take the place in the human body where the virus attaches itself, and I can shape a molecule to fill the gap in that virus that makes it ineffective to hurt the human body. I can look at chemical compounds with certain attributes for things like coatings or agricultural use cases. And the key is that I can calculate and predict the actual molecular properties without having to invent the molecule and then test it out. The other is around MRIs, magnetic resonance imaging scanner improvements. We can improve scanner sensitivity, or we could make them faster with the same sensitivity. We can use quantum inspired technologies to quantify client risks in new ways. We can help 5G by making software that handles all the different mobile user devices and all the different ways that we are sending out data to the core network. And so the core network could start to predict the type of data that's coming in a microsecond and give your phone access without even waiting for your phone to ask for the access. It could be predictive in having our phones and our technology connect to a radio access network. One of my favorites by far, because I've been a software developer, is verification and validation. So you could take a very complex physical software system like a fighter jet, and you can run the full specs through a quantum computer and start to like issue tree it out and look for places of possible failure. You can then identify those and lay them out for somebody else to determine how likely they are to fail and to look for mitigation strategies. So imagine if I can use a quantum computer to test an important piece of software, a mission critical piece of software, and I can find every place where it could possibly fail, and I can spend that time improving it before I go to market. The last one that always gets me excited is portfolio optimization. So I can optimize a portfolio. I can also, looking at it the other way, I could price risk. I could price equities or options or derivatives more effectively with quantum computers. That is very exciting because it's like beating the stock market with a quantum computer. The last one that we've seen talked about in the industry, right? These are just quantum technology cases. So these are all public. We are not sharing any classified information here. Secure terrestrial communications from space. So two people on Earth, they want to communicate. They may be in different countries, and they want what is effectively quantum secure communication, or communication that is so secure, even a quantum computer that can do factoring can't break it. Well, that's done today with quantum key distribution, QKD, and with other types of entangled technologies. Um, we also see this just on the Earth. I was reading where Chinese researchers have greatly exceeded the actual terrestrial distances where they can use entangled photons to have secure communications just on the Earth. We also see enhanced radar detection. And in fact, we were working on a grant for DOE to make radars even more sensitive. So imagine if I'm looking for um, background microwave pulses from space that help me understand cosmic microwave background radiation and the beginning of the universe. So I have a detector on Earth. If I can use quantum and I can entangle those sensors, I can make them 10, 100, 1,000 times more sensitive. I can also use quantum to reduce my footprint or my active radar footprint so that I can be passive in my radar. You can also use quantum technologies to detect movement and activity over long distances. So that's great. I could see a truck moving in the desert. I can see a submarine moving under the water. Or within the human body, I can see the pulses, the chemical reactions, and the activity deep within human tissues, which is great for medical uses. Being a little more fun, I could pick lottery winners, right? Quantum random number generation physically ensures randomness. So I could have millions of random numbers. If necessary, I could pick my lottery winners. I could set up my video games and my gaming solutions so that they can be truly random. And I can put those quantum random number generators into small devices like a phone or a desktop computer. We can make atomic clocks, which are the most precise items that mankind has ever made, and we can make them even more accurate. So that is a use case for decades where we've used quantum. Basically, an atomic clock is a quantum computer with 1 qubit. Finally, most fun, being a sports lover myself, is we can make better televisions, better LED displays, the big screens in the stadiums, and better lighting solutions for everyday uses using quantum dots. And a quantum dot takes in a signal, let's say an electron, and it sends out a photon of a very, very specific frequency or color. And so it is perfect in its ability to replicate that color over and over and over again if you send in one electron. So it's a tremendous capability there. It's to talk about how a commercial enterprise should consider adopting quantum computing. And I must point out that a colleague of mine, Nick Farina, hit the nail on the head in a recent tweet when he said, "Why are companies spending millions of dollars lining up access to quantum computers or talent, quantum talent? It's for learning. You don't want to be just starting to figure out quantum computing in 2025 when maybe the technology is actually available, widely used, able to deliver massive amounts of quantum advantage, and you're starting in 2025, yet your main competitor has been working on it since 2020. That 5 years of learning allows them to hit the ground running right when the technology is mature enough. Think of it as like the early adopters in cloud computing or early adopters in mainframe computing. These are companies or these are governments that have gotten in early, learned the skills, built the capabilities, and and blew away their markets basically. So let's talk about a very simple 5-step process. And this is our opinion, Chicago Quantum's opinion on how a client should approach learning and developing a quantum computing capability. The first is just begin to learn about quantum computing. Read about it. I mean, we tweet. There's probably 400 people that are active on Twitter. You can see things in Reddit. You can read books. There's online courses, or you can hire a firm to come in and give you a 1 day or a 2 day primer on quantum computing. Just get a feel for it, where it's at, who's playing in the space. See if your competitors are in the space as well. Then, when you've figured out that this is interesting and you'd like to do a little bit more, build your team of evangelists or volunteers. And what we've seen that seems to work is that companies will hire maybe one person or part time efforts of one person who's their quantum computing evangelist. And then they look in the firm or the company or the organization to find volunteers or evangelists to bring together. They may work nights and weekends, they may work on um, specific research projects. And then over time, as you start to see value, you can start to increase the investment. But it's a very small investment for most companies to hire one or two people or to use one or two FTEs of talent throughout their organization. The next is to identify and focus on one use case that would create significant value. So we've talked about a number of use cases. Maybe in your case, the one case would be better logistics or improving a supply chain, improving a manufacturing process. It could be something around sensing. And so find one and focus all your efforts on it. I use this as an example because for our own firm, when we started talking about quantum computing, clients would have many, many questions. The conversations would go all over the place. But once we started talking about our focus on one topic, one problem to solve, the questions they asked got a lot better, a lot more specific and a lot more detailed. Our answers became a lot more thoughtful because we had experience in actually running algorithms on quantum computers or classical computers. We'd been thinking through how to make that one use case work. And as a result, the experience that we built was very pragmatic. And so for a company, I would say do the same thing. Even if it's the wrong use case to start with, pick one, build your capability, and then you can always add other use cases in the future. The next is you want to tap into this very small ecosystem. Now, how do you find them? How did we find them? Well, the first is industry providers. If you do a Google search on the quantum conference circuit, the quantum computing industry conferences, you'll see the names. Just look at the sponsors. Pretty much those are your industry providers. Academic institutions, there's more than a dozen. My guess is if you look for a quantum degree program, you'll find quantum institutions. Uh, for ourselves, just a shout out to the Chicago Quantum Exchange, which is based out of the University of Chicago and has participation from University of Illinois, University of Wisconsin, Northwestern, Purdue, and other firms. Um, Chicago Quantum Exchange is just one of many organizations that have quantum computing programs, PhDs, postdocs that are available for your support. Scientific labs and research groups. So there's two kinds. The Department of Energy has a class of national labs. You've heard of them: Oak Ridge National Lab, Los Alamos, Berkeley, Lawrence Livermore, Fermilab, and Argonne. So each of those labs has a commercialization arm where you can learn about the research they're doing, and they love to partner because if you can provide funding, they can possibly have the expertise and help you develop something. We've reached out to the national labs, and it's a tremendous amount of expertise. Then you have the research groups, and some of these are part of your large Fortune 500 companies, and they're also, not surprisingly, willing to partner with clients or customers of their firm, or in our case, partnering with another consulting or research group, and then start to make some targeted investments in learning, research, and development. My final point, again, another shout out to Nick Farina, is to be visible and be open and collaborative in your efforts. have a GitHub, start a project, publish some of your early results, and put it out there. Because what will happen is you'll attract new talent, more talent to your organization. And there is a possibility that your market cap and your attractiveness to customers goes up because you're investing in new innovative areas. So, just to replay it, if I'm going to talk to a commercial enterprise, I would say begin to learn about quantum computing, maybe bring in your data analytics team, your mathematics team, your research team. And then let's talk about building your own team, maybe around one core person, one core employee, and a set of evangelists and volunteers. We would recommend then using consultants or facilitators to try to make that team as effective as possible. Then identify and focus on one use case. Pick one. And so again, you can tap into a consultant or a project management organization that can help you run that process. Then, once you've narrowed your focus, start tapping into the industry providers. And we've run through a list of at least 30 or 40 of them: academic institutions, scientific labs, and corporate research groups, to start to build a little hub, a little nexus of research and activity, and start to make those targeted investments. And then, in all cases, to the extent you can protect your trade secrets, but be open, be visible, and be collaborative in your efforts. So I want to thank you for listening. This is Jeffrey Cohen, President and founder of U.S. Advanced Computing Infrastructures. Today is February 14th. And again, thank you very much for your time and your attention. Take care.